What if I told you a free AI beats OpenAI and Claude for pennies? DeepSeek is here, and it's game over. Let my AI assistant walk you through it.
Welcome to Dev Basics with AI. In this episode of the DeepSeek AI Revolution, I'm your expert assistant, here to make even the most complex AI concepts easy to understand. We'll explore DeepSeek v3 and R1, showing how v3 matches Meta's Llama 3.1 performance at a fraction of the cost. Stick with me, and by the end, you'll truly understand the breakthroughs shaping the future of AI. DeepSeek uses a sparse model solution to tackle the dense problem of standard models like Llama 3.1. While dense models activate every parameter, DeepSeek activates only a fraction of its brain, using a specialized router to send data only to the specific parts of the neural network equipped to handle it. Dense models activate all parameters every time, but sparse models route tasks to only the experts who need them. The mixture of experts, or MOE, architecture in DeepSeek 5.3 boasts 671 billion total parameters, yet only activates 37 billion parameters per generated token. This is achieved by having a shared expert for foundational knowledge and dynamically routing complex tasks to hyper-specialized experts. Load balancing in MOE models is critical. Early models suffered from routing collapse and hardware bottlenecks. Traditionally, engineers used an auxiliary loss penalty to fix unbalance, but this interfered with the AI's core intelligence. DeepSeek v3 breaks the dilemma with Aux-Loss-Free load balancing. It uses a dynamic bias term, or a traffic light system, that adjusts routing scores based on historical load. This redirects overflows to idle experts without penalizing the model's intelligence. The memory bottleneck, or KV cache, is a major issue in standard multi-head attention. As context grows, duplicating keys and values across multiple attention heads consumes massive GPU VRAM, leading to memory bandwidth bottlenecks and crashes. Storing all previous words in memory creates a bottleneck. Multi-head latent attention compresses this data, making inference faster and cheaper. Multi-head latent attention, or MLA, is DeepSeek's compression engine. It projects keys and values into a compressed latent space, drastically reducing the KV cache size by up to 93%. This shift to a compute-bound workload allows DeepSeek v3 to handle massive 128,000 token context windows flawlessly. DeepSeek v3 is one of the first models trained using FP8, or 8-bit floating point mixed precision. This low-precision training cuts the memory footprint in half, effectively doubling the training speed, while fine-grained quantization and outlier protection maintain stability. Dual-pipe parallelism addresses the communication overhead during training on thousands of GPUs. This custom algorithm uses bidirectional pipeline scheduling to flawlessly overlap computation and cross-node communication, achieving near-zero overhead. This enabled processing 14.8 trillion tokens in 2 months. Multi-token prediction, or MTP, enables sequential forecasting, predicting multiple future tokens at once. This densifies training signals and allows for speculative decoding during deployment, increasing generation speed by up to 1.8x and lowering user latency. DeepSeek R10 focuses on reasoning models. It uses pure reinforcement learning, skipping human examples, and focuses on verifiable tasks like math and coding. Through millions of iterations, the AI achieves emergent evolution, naturally figuring out complex rules completely on its own. Group Relative Policy Optimization, or GRPO, eliminates the need for a massive critic model, which typically doubles memory costs in standard reinforcement learning. GRPO grades attempts relative to the group average, instantly teaching the model which coding patterns are most efficient. By exploring on its own, DeepSeek R1 develops reasoning behaviors organically, learning to self-correct without human guidance. Through unrestricted exploration in reinforcement learning, DeepSeek R10 achieved spontaneous cognitive emergence. The model independently initiated a self-correction process, pausing to reevaluate its steps without external prompting. The DeepSeek R1 pipeline starts with cold start SFT, collecting high-quality examples. Then, reasoning RL applies GRPO. Next, rejection SFT generates successful reasoning traces. Finally, alignment RL ensures the model is helpful and language consistent. Knowledge distillation is the process of using a massive model, DeepSeek R1, to train smaller, cheaper models. By using 800,000 reasoning outputs as textbooks, the smaller DeepSeek R1 DistillQuen 7B model dramatically outperforms massive older models, proving that high-quality data is paramount. In hardware and deployment, DeepSeek offers accessible cloud options for distilled 70B models, local execution for highly optimized 7B and 14B models on consumer hardware, and high-throughput commercial deployment by separating pre-filling and decoding processes. You have successfully mastered the architectural marvels behind DeepSeek. Master the future of AI by subscribing to Dev Basics with AI as we continue to break down complex white papers into actionable knowledge.